circular flume. Now this is cutting edge sedimentology. It's only happened in the last several years now. This unassuming looking scientist here, German background, but he's at this university, demonstrated the deposition of fine-grained muds in fast currents. In other words, he had this kind of contraption that circulated water and mud around, and then he began to decrease the velocity of the flow, and he noticed what happened. How did the mud settle to the bottom, and how did it do it, and what was the velocity, and he could measure it all and control it under conditions. And this is called the mudstone revolution. Prior to 2007, conventional wisdom in sedimentology regarded mudstone as a product of extremely slow vertical suspension, like you had in that model, the Delta model, right? In very quiet waters. In other words, 2/3 of the sedimentary rock record probably required vast periods of time to accumulate. It was a problem prior to 2007 for a flood geologist to explain 2/3 of the sedimentary rock record. That's all changed because of this guy's work, right? He found that because the mud flocculate, clay particles flocculate, it can be deposited like this in a current, and it can be deposited rapidly. You don't require millions of years. All that goes out the window. And this is just some of the research here. So he found out that you can get these little accumulations of you from the bottom of the flume tank here, right? Of flocculated clay in a current, and then you even get these kind of dune forms that have tilted beds inside of them like this, and it looks just like your crossbedding in the Navajo sandstone and places like that in the desert Southwest. Amazing stuff. And as the current wanes below a threshold, a certain threshold, the ripples coalesce. Eventually, they form a bed, and so you get a whole, bed of these fine clay particles. The floccules move in a current just as if they were sand-sized, even though each floccule is composed of far smaller particles. No one ever knew that clay behaved this way. The implications for rapid accumulation of sedimentary rock record are profound. Right? So this is what had, in 2007, had a bunch of us creationists standing on our heads going, wow, this is life-changing stuff if you're a flood geologist, right? And most of you are looking at me like, you gotta be off your rocker.
That's amazing. Cool.
Yeah.
A through F is bird's eye view.
This is that's looking from underneath the tank. This is
the ones on the right.
plexiglass.
The ones on the right.
Yeah. This is looking from underneath also.
Oh, okay.
Yeah. So you're seeing the sediment build up on the plexiglass, kind of clear plexiglass tank. Yeah.
So are those lines that you're saying on the drawing there representing striations? You're saying?
Well, you don't call them striations. They're actually crossbeds.
What is that?
It's building up like as the current goes this way, it builds up layers, stacks, layers.
But they're angled.
Right. So if you looked at it, actually, it could look like different, like it appeared to be laid down at many different times. Is that what you're saying?
Not really, no. It's happening, well, it is happening at different times because this bed obviously came in first, and that one came on top with the next one, the next one, the next one.
Right.
So the current's going this way and it's building up these layers like this.
Okay.
So would this explain like cochineal sandstone?
Yeah,
That's a lot of
same
crossbedding.
Yeah, crossbedding. It's not fundamentally different than that, you know. Right. So welcome to the mud rock revolution. Right. Now, that's all fun and nice. If it doesn't apply to the real rocks, it's just so much talk, right? But in fact, since that work was done, they've gone out into the field and they've looked more carefully at a lot of your ancient black shales. And what have they found? Under close scrutiny, many of these shales from the ancient rock record reveal cross-laminating, these kind of crossbeds that match those produced in the lab. This kind of agreement essentially proves that these ancient shales form rapidly in moving currents, not slowly and gradually under stagnant delta model conditions. Right? This is right out of this core from the earth. This one happens to be from Wisconsin, right? And geologists are looking a lot more carefully at those shales because it's very subtle, but you can see the crossbeds. In some cases, you can see other things too when you get to it. And this was published in this journal over here, in case anybody's interested. All right, so the significance of these flume studies, just to kind of tie a knot around this one. Mud rocks, which make up 2/3 of the sedimentary rock record, can accumulate rapidly, number one. Number two, bed forms in at least some of these ancient black shales indicate they actually did accumulate rapidly. And who cares? I'll tell you who cares. Uniformitarian geologists care because they've gone back to the blackboard. All right? Back to the drawing board, I mean. And they don't know where, how do we explain these things now? It really upset the apple cart, right? It's important to economic geologists who are interested in exploring for oil and gas deposits. You want to know how those things form in order to try to explore for them, right? And it's of interest to flood geologists who want to know the true nature of the sedimentary rock record. I want to know what the truth is. If there was a global flood that happened in Earth history, it left a mark on this Earth. And I as a geologist, woe be to me if I can't point to the rocks and say, there it is. Because I can't just say, well, there was a global world-destroying flood, but it left no evidence of it behind. No. That's just not what I would call giving answers for the hope that's within me, as Peter says. Right? Okay, so let's go on to finding number two. Finding number two is what we call the black shale paradox. And I'm going to give you a lot of detail, but just kind of catch the high points of it, if you will. Don't get too hung up on it. This is kind of interesting. Notice in the Delta model, they had this anoxic conditions, right? Low oxygen conditions, because that's what you need to pickle all that organic matter so it doesn't rot. If bacteria get in there, that ruins the whole thing. You have no black shale. Well, they found fossils in some of these black shales, right? Including extraordinary preservation of some of these things. But anyway, the key is that they found creatures that are bottom-dwelling creatures as well as swimming creatures buried in the same layers. Now, you might not think too much about that, but things like worms and this particular kind of thing called a